5.3, solving trig equations. So here was our warm-up that we kind of talked about in class, and some of the things that we talked about were number one, when is tangent positive and negative, in which quadrants would that happen? And we used all students take calculus. And this is cosine and secant are positive here in the fourth quadrant. Sine and cosecant are positive in the second. Tangent and cotangent are positive in the third. And all of them are positive in the first. So tangent would be positive in the first quadrant and the third, and it would be negative in the second quadrant and the fourth quadrant. Question 2 and 3 are kind of related in terms of the process. First of all, we need to figure out, using the unit circle, where is tangent equal to this value? And we're trying to figure out what the angle is. Basically, we're trying to figure out where that exists. When does that happen? What's the angle? So by understanding the quadrants, where they're positive and where they're negative, are going to help us with that. The other thing that we need to realize is tangent. To figure out tangent, we needed this triangle on the unit circle. And this was y, and this was x, and this was r, and our r unit circle happened to be 1. But to figure out tangent of this angle, we would do our y divided by our x. And so we're going to try to focus on in terms of how our 7th grade math teacher would have written it. So if we think about this, that y divided by x, I need a square root of 3 on top. Square root of 3 over 2 and 1/2 are going to be the quadrants that always go together. If square root of 3 over 2 is the x value, then the y value is going to be 1/2. Vice versa. If the square root of 3 over 2 is the x value or the y value, then the x value is going to be 1/2. So you're when you're dividing, going to be canceling those 2's out. So if I look at the y divided by x, your 7th grade math teacher talked about that you're going to change division to multiplication of fractions, and you're going to flip the second fraction. Because square root of 3 is on top, that means that could not have been flipped. So that has to be our y value. So for number 2, we know, it's no longer working right now. For number 2, did weird things. For number 2, we know that the y value has to be equal to square root of 3 over 2. The other thing is we know we're in quadrant 1 and quadrant 3. And I don't know why I put a random comma in there. So if I look at quadrant 1 first, where is y equal to square root of 3 over 2? And that would be at pi over 3. And let's just test to see if that does give us the value of square root of 3 over 2. So y divided by x is going to be square root of 3 over 2 divided by 1/2. Which is going to give me square root of 3 divided by 2 times 2 over 1. Do you see how those 2's are going away? And yes, we did get square root of 3. So this is an answer. The other place that it exists is there's a y value of square root of 3 over 2 on quadrant 3, and that is at 4 pi over 3. And you might be thinking, well, wait a minute, that says negative square root of 3. Well, if you notice, the y value and the x values are both negatives. A negative divided by a negative is going to make that negative go away. So once again, we're doing y divided by x, and that's going to give me negative square root of 3 over 2 times negative 2 over 1. The negatives and the 2's cancel, leaving you square root of 3. So both of those would be the answer. If you look at number 3, the square root of 3 has to be on the bottom, which means for number 3, square root of 3 over 2 has to be the x value, because that's going to be the one that's flipped with tangent. So still looking at the positive, so we're still going to be in quadrant 1 and quadrant 3. I almost wrote quadrant 2. And so in quadrant 1, where is the x equal to square root of 3 over 2? And that is at pi over 6. And let's just prove it to make sure that's the case. So we'd have 1/2 y divided by x, and that's going to give me 1/2 times 2 over square root of 3. And you see how that square root of 3 now jumped to the bottom. So that is an answer. The other one in quadrant 3 would be at 7 pi over 6. Because you'd have, nope, sorry, I'm looking, yeah. So you'd have 1/2 divided by your y, and it's negative 1/2, divided by a negative square root of 3 over 2, which is negative 1/2 times 2 over negative square root of 3. Negatives go, and you're left with, 1 over square root of 3. So the two answers for that answer would be pi over 6 and 7 pi over 6. Those are two places where that occurs. The other thing for question number 4 would be when you have an x squared equals 9. To solve this problem, you would take the square root. And you got to always be cognizant of the original problem when you're taking a square root. So 3 might be your first answer. Yes, 3 times 3 does equal 9. But there is another answer that does equal 9 using 3, and it would be negative 3. So whenever you take a square root, you're going to take plus and minus. Both of those would exist. In that case, that's going to happen in our trig functions when we're solving for these. That means we're going to have more than 2 answers. We might have 3, we might have 4. So keep in mind when you take a square root, you're doing the positive and the negative. Functions that have 2 pi, that would be sine and cosine, because secant and secant are going to have undefined variables, so those aren't ones that we're looking at right now. And then your trig function with pi would be tangent and cotangent. All right. So basic solving of trig functions. You solve for the angle and you list all the angles that fall into that interval. This function right here is the same process as this. This is the same process. So your Algebra 2 teacher told you to solve this in Algebra 1 by dividing by 2. And we're going to do that same exact concept here. We're going to divide both sides by 2. And we get sine of x, I don't know why I'm putting parentheses, is square root of 3 over 2. My first advice when you're solving these problems is first follow what quadrants is this happening. So sine is positive in the first and second quadrants. So those are the first two that we're going to look at. Actually, the only two. So we're looking for when the y value is square root of 3 over 2, and my x will be at pi over 3. And then I'm going to go quadrant 2, and when is my y value equal to square root of 3 over 2? And that would be at 2 pi over 3. So those are my answers. Okay, this problem number 2 looks exactly like this, so you got to focus. What you did in Algebra 2 and Algebra 1 are still they're still playing in. So if you have a 2x plus 6 equals x plus 8, my first advice is, because I always like to get my x's together, is to subtract, and I always struggled with negatives in high school. So I will always move over my x's first and get that negative to go away, and not have a negative 2x going to the other side. So I'm going to do that same concept. That cosecant is a something we don't know. So if I subtract cosecant from both sides, I get cosecant x plus 6 is equal to 8. Then I'm going to subtract 6 from both sides. I get cosecant x is equal to 2. Now it's hard to deal with sine and cosine. Well, it's easy to do with sine and cosine on the unit circle, but cosecant is not readily easily identified. So it's better to put it in terms of sine, and I would just make cosecant as sine and then do cross products. Divide by 2. And so now we're going to be looking for when sine is equal to 1/2. Okay? And that's going to happen in first quadrant and second quadrant. In the first quadrant, it's going to be at pi over 6. At the second quadrant, it is going to be at 5 pi over 6. same thing you did before. Well, now we got tangents, so now we're going to be dealing with dividing and who needs to be flipped. So I'm going to get rid of the tangent because if I move the 2 tangent, I'm going to have a negative tangent. And that would stress me out. So, but you can definitely do it. So it gives you a negative square root of 3 is equal to a tangent x. Okay, so tangent x is equal to a negative square root of 3. This is saying that tangent is negative, and so tangent will be negative in the 2nd and 4th quadrants. And I do notice the square root of 3 is on top, so that means y needs to be the square root of 3 over 2. It has to be that setup, because if I flip it, square root of 3 would be on the bottom. So, and it can be either positive or negative, because it should, with the points, give us, when we divide it out, a negative answer. Okay, so I'm in quadrant 2. My y value equaling square root of 3 over 2 would be at 2 pi over 3, and I'm just going to verify that. So square root of 3 over 2 divided by negative 1/2 would give me square root of 3 over 2 times 2 over negative 1, and if you do see, the negative does appear, and we have it. So that is a valid solution. The 4th quadrant, where I get a y value equaling to a square root of 3 over 2, would be at 5 pi over 3. And that is negative square root of 3 divided by 2 divided by 1/2. And we're going to have square root of 3 over 2 times 2 over 1. And that gives us a negative square root of 3. So those work out. These are our 2 answers right there. Okay, 4 sine squared over or equals 3. So the first thing I'm going to do is solve for sine squared, and that means dividing both sides by 4. And I got sine squared x is equal to 3/4. To get rid of the squared, I'm going to take the square root of both sides. Remember, I'm going to take a positive and a negative. And I don't know if you remember, but in geometry you learned this concept that you can take a square root of the top and the bottom, and that's still a valid mathematical statement. And this is our answer. So we're looking for where is sine positive square root of 3 over 2, and where is it negative square root of 3 over 2. And if you notice that will be all 4 quadrants, because your positives will be 1st and 2nd, the negatives will be 3rd and 4th. So you're just looking for when your y values are equal to square root of 3 over 2. So you just go around the unit circle. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Sometimes we're going to need to factor, and we're going to add or subtract to get all the terms on one side of the equations, because you have to equal 0, just like they did in Algebra 2 when you have those big x squared problems. This one, when you have 2 terms, you should really look for a common factor, because that's probably what's going to need to come out. If you notice, they both have signs, so I'm going to pull out a sign, and I'm going to show something that I show in my class. I look at whatever I'm going to factor out. That is what I'm dividing. And this right here, this step, I'm actually doing in my head. But whatever's on that bottom of that fraction, that's what's getting pulled out of this equation. So sine goes into 2 sine squared, 2 sine times. And sine goes into square root of 3 sine, square root of 3 times. And then this is just like the zero product law, or property, in which you set each of these equal to 0 and solve. So I'm going to do the same concept here. I'm going to figure out when is sine equal to 0, and I'm actually going to go and figure this value out first before I so I'm going to subtract square root of 3. I'm left with 2 sine x is equal to a negative square root of 3 divided by 2. So I'm pretty fast when it comes to simplifying equations and solving for variables of x. I'm just applying the algebraic equations that you used before. Sorry, the Doceri desktop trial is right there, but that is a negative square root of 3 over 2. So what I'm looking for is, and I'm looking for when sine is 0, and when sine is 0, the y value is 0, and that would be at 0 and pi and 2 pi. Now on your homework, you have these directions. You have this. You find all the values that happen within this interval. If this were written on this page right now, I could not list 2 pi because this parenthesis means that's not included in the data. But since there's no directions given here, I'm including that. But I'm going to put a little X here just in case you use these for your quiz. And you know, if you've got this scenario, you cannot include 2 pi. So now negative square root of 3 over 2 would be in quadrants 3 and 4. And that would be at 4 pi over 3 and 5 pi over 3. So all of these would be my answers for that solution. If you have a situation where you have 4 things, you're going to solve by grouping. And if you notice in the first 2 terms and the last 2 terms, they have things that they share in common. If you can notice those right away, it makes it pretty easy. I noticed in the first set of numbers that these guys share a cosine in common. So I'm going to divide by cosine. What I'm showing right here is what I'm actually doing in my head when I'm doing these problems. But whatever's on the bottom, that's what I'm pulling out. So this is 2 sine x plus 1. Now, with the next 2 terms, I really need it to have this so that I'll be able to pull even that term out from my grouping scenario. So if you notice, those guys share a negative 1 in common. And if you did notice that, you'll get the same things in both parentheses. Then these guys both share this. So you have 2 sine x plus 1. And you have cosine x minus 1, and you both equal 0. And I'm just going to go and solve for cosine and solve for sine so that I can figure out what quadrants I'm going for. So if you need to, stop the video so that you can verify that you can do this on your own. Okay, so the first one is sine equaling negative 1/2, and that's going to be in quadrants 2 and 4. And cosine equaling 1, well, those are going to be in, that's going to be on the x or y axis for those whenever you have 1s or 0s. So that's only going to happen in one place. So my values, let's do the sine first. Negative 1/2, my y equaling negative 1/2 is 7 pi over 6, and, did I do that right? Yep, and 11 pi over 6. And then cosine equaling 0 would happen at 0 and pi. Once again, if there's no directions, you would include the 2 pi, but normally your directions on your homework are going to be given in this interval. That's a bracket, and this is going to be a parenthesis. Number 7 is where we're actually going to factor, and my advice is to factor it like you would in Algebra 2 or Algebra 1 and write these, instead of saying secants, write them in x's instead, and then replace the x with secant when you're done. Oh, I was almost going to write secant right there. And I usually will do the box method unless I can factor something really quickly in my head. So 2 numbers that multiply together to give me -4, but yet subtract to give me -3. Those would be it. These guys share a negative in common and a 2x. These guys share an x. And this to be positive. I don't know why I put that there. I was like, wait, it's not working out when I factor in. So always I'm looking for this. How do I get a -2? And if I had a -1 here and a -2 there, that wouldn't have worked out. That made it positive. So I got it all work out. The next thing you're going to do is you're going to come over here, and now we're going to replace those x's with secants. So in the first one we have 2 secant x plus 1, and the other one is going to be secant x minus 2 equals 0. So I'm going to solve for each of those. Okay. So algebra hopefully is not freaking you out at this stage in your math career. I can't really have a secant on the unit circle. It's hard to determine. It does exist, but you have to think of the reciprocal. So I'm going to do 1 over cosine and then do a proportion. Okay. And for that one we got cosine x is equal to -2. And then let's do this one. So plus 2 plus 2. Secant x is equal to 2. 1 over cosine x is equal to 2. It's going to give you, when I do a proportion, 2 cosine x is equal to 1. Divide both sides by 2. Cosine x is equal to 1/2. Okay, the first solution, cosine x is equal to -2. If you notice, nowhere on that unit circle do I have a -2 as the x value. So this is, it doesn't exist for that one. But for the other one, my angle of 1/2, well, that's going to occur in the fourth and first quadrant. So in the first quadrant of 1/2, it would be pi over 6. And in the fourth quadrant, it would be 5, did I do right? Nope, I did it wrong already. Sorry, guys. I'm looking for when cosine, the x value, for some reason I like sine better. When the x value is equal to 1/2 is pi over 3. And when the x value is equal to 1/2 would be 5 pi over 3. Things that when I was making that mistake before is I noticed this had a 6 and the other quadrant had a 3. They're going to be the same when they're dealing with those. So that was one way I was checking my answer going, oop, nope, that's not right. Okay, all done.